All right, so moving on to lecture 11, part B. Now, in this part, we're going to talk about something totally different. In this one, we're going to look at how much do atoms weigh. Now, before I get into that, let me remind you of a couple ideas you've already heard about. And to help you understand them, actually, maybe I should put up a periodic table. So let's go ahead and do that. And we've already talked about two terms that is going to kind of be related to what you're hearing about right now. One of them, oh, you heard about the word atomic number. Now, what is atomic number again? Oh, atomic number is the number of protons in an atom. The number of protons in an atom. Now, that's the symbol that you've seen off the periodic table, right? Or that goes along with the symbol, the number, I should say. Like, for example, for chlorine, it's the 17. That's called the atomic number. All right. Now, I've talked about one other idea that in a previous lecture, in a previous set of lectures, and that was called the mass number. Now, do you remember what the mass number is? It's two things added together. What is it? Okay, hopefully you remembered. It's the number of protons plus the number of neutrons. And the way that we came up with that, typically I gave you a symbol, right? Maybe something like this, 3717Cl. And that 37, this number would be the mass number. And then the number, the 17, is the atomic number. All right, now in this lecture, we're going to hear about something that kind of sounds similar to mass number, but it's a totally different idea. And really, this idea is called the atomic mass. Now, the atomic mass is the weight of an atom, the average weight of an atom. And in fact, it's the other number you've been seeing on the periodic table. So for aluminum, do you see where it says 26.98 here? That number is called the atomic mass. Don't confuse it with mass number, two different things. It's the weight, the average weight of an aluminum atom, 26.98. All right, weighing atoms, how do we do that? And what do you mean by the average weight? Well, let's talk about that. So 26.98 is the average weight of an aluminum atom. All right, so to be a little bit more exact, that number for aluminum again, 26.98, it is the average mass of an element, the average weight of an aluminum atom, taking into account all the isotopes that exist, all the different forms of that atom. Now, what do I mean by the word isotope again? Okay, so hopefully that rings a bell. What do I mean by isotope? So an isotope is just two forms of the same element. They have a different mass number, right? So they have a different number of neutrons. You could say it that way too. All right, so we're going to take into account when we find the weight that there's more than one kind of aluminum atom in the world. Now, how do we do that? Well, it's a little calculation. I'm going to go over in just a minute. Now, before I do that, there's going to be a unit on these weights. And the unit that we weigh atoms in is called the atomic mass unit. Atoms are weighed in atomic mass units. Now, instead of saying atomic mass units, usually we abbreviate it AMU. So we weigh atoms in AMU. On average, aluminum weighs 26.98 AMU. So AMU is just a unit. It's like grams or kilograms or pounds or ounces. It's a unit of weight. Now, we probably won't ever do this, but you could even convert it from AMU to kilograms. Let me put up the conversion factor. Again, probably won't ever use this, but an AMU is just a unit. It's like grams or ounces or pounds. You could go from this unit to kilograms if you needed to. This is the conversion factor from AMU to kilograms. All right, so atoms are weighed in AMU. Now, how do we get the average weight? Well, the way that we get the average weight of an atom, and again, we're going to take into account all the different isotopes that exist for aluminum or whatever atom it might be, we're going to do this. We're going to say the average weight, or instead of saying average weight, we just call it the atomic mass, is equal to the weight of the first isotope of some atom times its amount in decimal form. All right, what do I mean by that? I'm going to explain it in a minute when we get to our example. Plus the weight of the second isotope, the second type of the same atom, times its amount in decimal form. And then you keep doing that. If there's 3 isotopes, you would do this 3 times. Or if there's 4 isotopes, you would keep doing it over and over and add the answers together, add them together. Okay? All right, so with that, let's do an example. This will probably make more sense once we do an example. All right, so let's flip over. I have an example. Let's get to it. All right, so how do you find this atomic mass? How do you find the average weight of an element? Well, what chemists do, scientists do, is they gather up a bunch of different atoms, and then for each kind of element, they'll figure out how many different forms are there, how many different isotopes are there. So for lithium, it turns out there's 2 forms of lithium. There's 2 isotopes of a lithium. So the first one over here, I guess this is called lithium-6. And then the other form is called lithium-7. Now, what makes them different? Well, their number of neutrons is different. In lithium-6, right, there would be 3 neutrons if you subtract. And in lithium-7, if you subtract, there's 4 neutrons. Now, once they figure out that there's 2 kinds of lithium atoms out there in the universe, the other thing they do is they weigh each type. Now, you can do this using an instrument. It's called a mass spectrometer. And you can figure out the weight of each form of lithium. And when they did that, let's see, let me tell you what they came up with. Lithium-6, this first type of lithium atom, it weighs 6.015, and then the unit on that is AMU. That is the unit we weigh atoms in, 6.015 AMU. Now, when you weigh the other form of lithium, see it's got an extra neutron, it's got 4 neutrons, so it's going to weigh a little bit more. It weighs 7.016 AMU. Now, the other thing they do, besides figuring out the weight of each type of lithium atom, is they figure out how common each lithium atom is. So it turns out, if you gather up a bunch of lithium atoms from the universe, you're going to find that a little over 7%, about 7.5% of all the lithium in the universe is lithium-6. The other 92.5% is lithium-7. So lithium-7 is way more common. So what we're going to do is we're going to figure out the average weight. But we don't want to just like add them up and divide by 2. We want to take into account that there is a whole lot more lithium-7 in the world than lithium-6. And that's what this equation does. It takes into account that lithium-7 is way more common. So the way we use it exactly is we're going to take the first isotope, lithium-6, I guess, and we're going to take its weight, and we're going to multiply it times the amount of lithium-6 in the world. Now, the amount, not as, by the way, the amount, we call that the abundance, not as a percentage. It's got to be a decimal number. So how do you make 7.5% a decimal number? Well, the way you make it a decimal number is you divide by 100. You divide by 100. Another way of saying this, you could say you move it over the decimal over 2 places. So if I take 7.5% and I make it a decimal number, divide by 100, this is what you're going to get, 0.0750. That's the number I'm using, the amount in as a decimal, 0.0750. Now, we're going to do that for the second isotope too. We're going to take the weight of lithium-7, weighs 7.016 AMU, and we're going to multiply it times the amount of it we find in the world. 92.5%, So again, I can't use that. You have to have it as a decimal number. So you could either think I'm going to move the decimal over twice to the left, or you could think I'm going to divide it by 100. If you divide it by 100, you get this. You get 0.925. And that's what we would use. All right, so don't put in percentages here. If you do, you're not going to get the right answer. All right. And then that should be what we should do. So it'll be 6.015 times 0.070, and then you're going to add 7.06 times 0.925. If you do this correctly in your calculator, it's a little hard for me to show you the work, but it should, basically just make sure you enter it correctly. If you're doing it correctly, and I would highly suggest you try it out just to make sure you could do this, you should be getting 6.94 AMU. 6.94 AMU is what you should come up with. All right, with that, let's check to see if that seems right. Okay, so does that seem right? Well, again, what we're trying to figure out is the average weight of an atom. That average weight is on the periodic table. So a minute ago for lithium, we got 6.94. If you look under the symbol for lithium, that's pretty much what you see, all right? So maybe they have an extra digit more than I gave you. But basically, that's what we came up with, right? 6.94 AMU. So what are those numbers on the periodic table? They're the average weight of an element. All right, let's do another example or two, huh? So coming up with these average weights and making sure we understand where they're coming from. Let me flip over and we'll do another one here. All right, let's do another example. So for this example, we're going to work with magnesium. And it turns out with magnesium, there's actually three forms of magnesium. There's three isotopes of magnesium. Some magnesium atoms are magnesium-24. Some magnesium atoms are magnesium-25. And some, oh, this kind of got messed up as far as the location. Some are magnesium-26 atoms. All right, I'm going to write it. It should be really here. All right, now, each one of those guys has different numbers of neutrons, right? So since they have different numbers of neutrons, they're going to weigh slightly different amounts. You can see the weights up there already. So every form weighs a little bit different amount, and it turns out some forms of magnesium are more common than other forms. So if you gather up a bunch of magnesium in the universe, you will find that about 79% of all the magnesium in the universe is magnesium-24. About 10% of all the magnesium in the universe is magnesium-25. And I guess the remainder, about 11% of all the magnesium in the universe is magnesium-26. All right, so what I want to figure out based on this, on average, what does a magnesium atom weigh? And I'm going to make sure I take into account that one of them is way more common than the other one, the magnesium-24. So the way we do that is this equation, right? It's going to be the mass of the first isotope times its amount as a decimal number, plus the mass of the second isotope times its decimal amount as a decimal number. Now let me remind you that there's actually three isotopes, so you actually have to do this a third time. It'll be the mass as isotope 3 times its amount as a decimal number. If there were 4 of them, you'd keep on doing this 4 times or 5 times or however many isotopes there are, and then you would add to get your total. All right, so let's go ahead and work it out. Let's just double check you got this figured out. All right, so we're going to take the weight of the first isotope, magnesium-24. It weighs 23.985 AMU. And then we're going to multiply it times its amount as a decimal number. So what is 79% as a decimal number? What should you be using? Okay, so you divide by 100, right? And if you divide by 100, it actually is going to make it 0.79. So we'll be using 0.79 here. And then we're going to do that for the other forms. The weight of the second isotope, 24.987 AMU times its amount as a decimal number. Now again, not 10%. If you divide by 100, you get 0.1. You get 0.1. I'm writing all those zeros so we don't get mixed up on sig figs, right? So it's going to be times 0.1. And then we're going to do that the third time. The weight of the third isotope, a little over 25.983 AMU, times its amount as a decimal number. Not 11%. Should be 0.11. And if you work it out, yeah, that should go here. All right. So with that, let's go ahead and multiply them. And if you add them all together, so you would multiply the first two and get a total. And I actually kind of did it piece by piece, if just so you can kind of confirm that you can do this correctly on your calculator. If you multiply these two numbers together, you get 18.94. I'm going to write down all the digits. This is what my calculator said. And if I multiply the 24 times the 0.1, these two multiplied together are 2.4987. And if you multiply the 25.983 times 0.111, those get you 2.85813. So the total average weight, you have to add all these answers together. So after you multiply each one by its amount, the weight of each one by its amount, then you add to get the average, actually. And it's going to turn out to be, 24.30. Now, just to remind you, this is a number. There's going to be a unit on it. It's not just 24.30. It should be 24.30 AMU. That should be the unit on that answer. All right. So let's double check if it looks right. So the way we're going to know if it looks right is basically, this is the way you get that value off the periodic table. This should be the average weight off the periodic table for magnesium. Let's see if it matches up with what it's supposed to be. All right, did we do it right? Oh, magnesium, right here. Now you notice I got a slightly different answer. Maybe my numbers I gave you are a little bit different. I think we got 24.30 and the periodic table says 24.31. It's probably just like a rounding thing or something. But hey, pretty much we got the right answer. All right, so we're going to do a couple more problems like this. Let's see how it goes. Let's do a couple more. All right, so let me show you another example that's slightly different, a little bit different. All right, let's move on. So it says bromine has two naturally occurring isotopes. So there's two forms of bromine. One of them is bromine 79, and the other one is called bromine 81. All right, so there's two types of bromine, they're telling me. And they're also telling me the average atomic mass of bromine is 79.904. Now, even if they didn't tell me that was the average atomic mass, I would know that really, wouldn't I? Because it should be what we see underneath bromine on the periodic table. And your periodic table maybe has one less digit. But yeah, basically it's the same number. Okay, so bromine has two naturally occurring isotopes. There's two types of bromine. And the average weight of bromine is 79.904. All right, so what that is kind of telling me is that on average, that's the weight, okay? So let's see what they want me to do in this question. It says, with that information, if the natural abundance of bromine 79 is 50.69%, what is the abundance of bromine 81 in the world? All right, so we're doing something a little bit different in this question. So in the first question, they've already told me there's only two types of bromine. So I'm going to make a little pie chart here. There is bromine 79. There is bromine 81. Those are the two types of bromine. There's only two. They're telling me that if we gather up bromine, a little over 50% of the bromine in the world is bromine 79. So what they're asking me to do in this question, if the natural abundance, the amount of bromine 79 in the world is 70.69%, they're asking me what percent, how much bromine 81 is there in the world? Well, how would you figure that out? Well, one way I could figure it out is, right, all the isotopes, their total should add up to 100%, right? So there's only two types. The total of both of them should be 100%. So if I ask you, how much of the bromine in the world is bromine 81? We could figure that out by just saying, oh, together they're going to make 100%. So if 50% of them, a little over 50% of them, is bromine 79, the rest of them is bromine 81. So if you work it out, if you subtract, turns out the other ones, bromine 81, make up just under 50%, 49.31%. 49.31%. Okay. All right, so that's the first question. All right, there's another part to this one. All right. If the mass of a bromine 81 atom is 80.9163 AMU, what is the mass of bromine 79? If the mass of bromine 81 is 80.9163 AMU, so this form of bromine weighs 80.9163 AMU. What is the mass of the other type of bromine? All right, now this one's a little different, right? Because in the first two examples, what I did is I found the average mass, right? That's what I was looking for. Now, this time they're giving us the average mass, or we could even just look at the periodic table and find it. They're giving us the average mass, and they want to know the weight of one of the two types of bromine. All right, so we're going to use the same equation, but we're going to have to do a little bit something different. We're solving for something else this time. So let me remind you what that equation says. It says the average mass, the atomic mass, we could say, of an element is just the, we'll say the weight of isotope 1, and instead of saying isotope 1, I'm just going to say weight 1, isotope 1, times its abundance plus the weight of isotope 2 times its abundance. Now, which one we call 1 and which one we call 2 doesn't really matter. I am just going to say, for the heck of it, number 1, isotope 1 is the bromine 79. And I'm going to say, just for the heck of it, the other isotope is isotope 2, the bromine 81. All right. Now, what I'm really trying to solve for is what is the mass, what is the weight of the first isotope. I'm really trying to find this number right here. This is what I'm looking for. What is the weight of bromine 79? So to be able to do that, it's algebra, right? You got to plug in every other number. We'll probably have to do a little rearranging, and we should be able to come up with our answer. So let's see if we can do it. All right. So let's see. I need all the other numbers in that equation, and then I'm going to solve for the weight of bromine 79. So atomic mass goes on the left-hand side. That is the average weight, in other words. Try to pick a color that's going to work because I've used a bunch of colors already. Oh, we'll put in for the average mass, it's 79.904 AMU. The weight of this first isotope, the first form of bromine, bromine 79, I don't know. We're solving for that. But I do know its abundance. I do know that the amount of bromine 79 in the world, it's about 50%. Now, again, I have to make that a decimal number, so you don't want to put in 50.69%. You should be putting in 0.5069, okay? And then I'm going to do the same thing for the other form of bromine. The weight of it, now that one they tell me, bromine 81, oh, this is getting a little messy, weighs 80, a little over 80. And a minute ago, we found out that it, so that's a 1 there, was what percent of all the bromine in the world? Bromine 81, oh, that's what we did over here. Bromine 81 was 49% of all the bromine in the world. Now, don't put in 0.49, don't put in 49. You got to make it a decimal number. So it should be 0.4931. Sorry, it's a little messy. All right, so everything looks like it's in the right place. I got the average weight on the left. I've got the weight, the weight and the amounts on the right. Well, except for the one I don't know, right? I'm looking for the weight of bromine 79. At this point, it's algebra. All right. So let's see how we're going to do this. So first thing I'm going to do is there's all this stuff on the right-hand side. Let's see if we can kind of simplify it. And our goal is to get that weight by itself, right? Weight 1. So the first thing I'm going to do, like when I learned algebra back in forever ago, they always said, like, start with the stuff far away from what you're solving for. So that means what I'm going to do is I'm going to start by taking that 80.9163 number and multiply it times the 0.4931. So let me go ahead and start by getting these two numbers on the far right, and I'm going to multiply them together. So the total, when you multiply these two together, is going to be plus, and let me look at my notes, 3.9 AMU, 39.9, I should say AMU, misspoke there. All right, well, I'm still not done math-wise, am I? I'm trying to get weight all alone. So again, I'm going to deal with the stuff far away from weight. So let's get it simplified and let's get it away. So the next thing I'm going to do is I'm going to try to get the 39 to the other side. Now you notice right before the 39, there's a plus sign. So how do you move it to the other side? You do the opposite. So if there's a plus sign in front of the 39, to make it go to the other side, we will subtract. If you subtract 39 from both sides, and if I do it to the right, I got to do it to the left, what's going to happen to that 39 on the right-hand side? Plus 39 minus 39, they're going to cancel out, right? They're going to add up to 0. They're going to go away. So if I work it out, and gosh, I'm starting to run out of room. So this is going to cancel out. I think I can fit this step here, and then I might have to erase a little bit. So then what I would end up with, I have to do that to the left. So 79.904 minus the 39. Oh, yeah, that works out to be 40.004 AMU. All right, and then this is where we're at. All right, I'm going to rewrite it because, man, it's gotten messy on this tiny screen, and I need a little more room to finish it. All right, so let me erase just a little bit up here. We'll erase this. We don't need this anymore. This is the equation we started with. We already are using it. All right, I erase this area. Goodbye, goodbye. Okay, and I'm going to rewrite what I have just so you can see it, I hope, a little better. So you get 40 point, this is where I'm at. All right, and that equals weight 1 times 0.5069. All right, I'm hoping this math makes sense. All right, all this rearranging, oh yes. So now, we only got one more thing to do. What do I need to do to get weight alone? Well, my problem is weight is multiplied by 0.5069. So we got to get the 0.5069 over to the other side. So how do you move it to the other side? Well, there's a times sign in front of it. So you do the opposite and multiply. You're going to divide by 0.5069. Now, what's going to happen on the right? It's going to cancel the 0.5069, and we're left with this. All right, so I'll be left with this. The weight equals, and then it'll be 40.004 AMU. I'm going to have to erase a little bit more. Well, if you miss some of this, you can always rewind it, huh? Good thing about having this on video. And I'm going to erase the rest of this. Why not? Erase most of it. There you go. So then what I'd be left with is this divided by 0.5069. And if you actually get out your calculator and divide 40.004 divided by 0.5069, well, what do you come up with? You should be getting 78.92 AMU. Should weigh about 78 AMU. So the other version of bromine 79, I guess, weighs, this would be its weight. All right, 78.92, I should say. All right, so with that, a little bit different. You're using the same equation, but you had to solve for something else, and the math was a little tougher, wasn't it? All right, so we're going to do one more, and actually this one is going to be one of these pop-up questions that you're going to get a chance to practice this. All right, so let's see if it's making sense. I hope it is. Let's do a little practice one. All right, let me flip over and I'll put up the practice one for you. All right, so here's a little practice, right? So the way you get good at chemistry is you got to practice, right? So watching these videos, I hope it's helping you. Gosh, I hope it is. But you really got to practice to know for sure it's making sense. So this one, they're going to ask you to find the average mass, the average atomic mass, the atomic mass of some made-up element. All right, so this made-up element has 3 isotopes. They tell you the percent of each that exists. They tell you the weight of each form that exists. What is going to be the average weight? So make sure you're using that equation I showed you. You have the percentages and you have the weight of each version of this element. What is the average? All right, I'm not going to go over this. You're going to try it. Here should come up the pop-up. All right, I hope that you got the right answer on that one. If not, you know, we're going to probably practice this in our Zoom session. All right, so you get another chance there. So that's it for lecture B. There's a third part to this lecture, part C. We'll get to that momentarily.